Hello, my name is Rashmi. And this is my individual project for secure software engineering. And in this project, I applied both static application security testing and as well as I applied even the dynamic application security testing on the vulnerabilities for the OWASP juice shop application. So let me walk you through the setup, findings, comparison, and my reflections. Okay, this slide is was chosen because it is intentionally vulnerable and it aligned with the OWA's top 10 risk. So it's widely used for security education and as well as safe practice. So I deployed it locally using Docker to ensure testing was isolated and did not affect any production systems. So this setup allowed me to simulate the real attacks in controlled environment. In this slide, we can see static application security testing. So I used SendGrid OSS version which scans the source code for the insecure patterns, and for DSAT, I used OWASP ZAP version, so which simulates the runtime attacks, and my methodology was straightforward. Deploy the JSON, clone the source code, run SendGrid scan, then perform automated ZAP scan against the local host. So finally, I exported and analyzed the findings. So here, the SendGrid, it scanned all over the 1,000 files with 307 roles and reported around 51 findings. So the key vulnerabilities included MySQL injections, cross-site scripting, hard-coded secrets, and insecure use of eval functions. For example, in the login route, user input was directly concept directly into a SQL query, which could allow the attackers to bypass the authentications. So these findings highlight how static analysis can catch code the flaw before the deployment. So this slide is about the DSAT findings. So the ZAP on the other hand detected the runtime issues, and the most critical one were missing the content of the security policy headers. So the corpse misconfiguration and the timestamp disclosure. So these vulnerabilities are not visible in source code, but it will appear when the application is running. For instance, the missing CSP header means attackers could inject the malicious script into the browser. So one of the key things in security testing is to dealing with the false positive. So the automated tools often flag the issues that look suspicious, but they are not actually in the given context. So in my project, the SendGrid reported a prototype pollution vulnerabilities and even the regress denial of service pattern. However, so after checking the library version and usage, I confirmed these were already patched. Uh, Similarly, like the SAP flag, the X-powered header disclosure. So while technically it's true, this is a low severity issue that does not pose a real risk. And these steps ensured that developers would be focusing on fixing the real vulnerabilities rather than wasting time on the non-issues. So this slide explains about the comparative analysis. So it compares both tools. The same grips excels at detecting the insecure coding practices like SQL injection and hard-coded secrets, whereas ZEP excel at runtime misconfiguration using such as the missing the headers and as well as the cookies issues. Neither tools provide the complete coverage. Together, they complete each other and strengthen the software development life cycles. So this slide, it's all about the reflections. So mainly in this project, it gave me some hands-on experience with both static and as well as the dynamic testing. So I faced some challenges with the Docker networking when the juice shop failed to bind to the local host, and I had to adjust the WSL integrations and interpreting the same web rules, and it was too tricky. So as some findings were until some cross-checked with some reference. So these challenges taught me the importance of the environment setup and the manual verification. So overall, I learned that layer defense is essential in secure software engineering. So coming to the conclusion, so my SR and DSAT are complementary approaches. So the same grid helps the developer catch the insecure code early while SAP simulates the real attacks to uncover the runtime issues. Integrating both into the SSDLC ensures the stronger security coverage. And this project strengthened my skill in secure software testing, and it reinforced the importance of combining multiple approaches to protect the applications. Thank you.